Hello, welcome again to Photoelectric Academy, where we raise academic geniuses. We're waiting for your success in our exam WAEC, JAMB, SAT. Kindly follow this page on YouTube, subscribe on YouTube, follow us on TikTok, and download our UTME Learning app to be among the academic geniuses we are raising up. Today, we're going to look at this question and first on the fuse. This topic, a lot of students don't always like to focus on it because they are confused with many formulas that it has. But see how we're going to break it down already. Now, you have a system of advantage as you're preparing for JAMB or WAEC. And that system of advantage is called the UTME linear. Did you know that almost all these topics, the formulas, and everything that have been taught already in the UTME linear have? So today, we're going to look at this question. We have a question: photoelectrons are emitted with the maximum kinetic energy. Remember, we always told our students that if you also have a question in physics or in chemistry, write out the parameters you are giving out first. The parameters are the pointer that will direct you on which formula to use. So I'll quickly write out the parameter I'm giving: kinetic energy. They told me the kinetic energy is 2.2 times 10 raised to the power minus 19 joule. What else am I giving again? Now, I'm giving that 1 electron volt. 1 electron volt equals 1.6 times 10 raised to the power minus 19 joule. Then I'm asked to find stopping potential. Find stopping potential. Or no? So that's before we solve this question. Now, where is the genesis of where all formulas emanate from under this field? Now, see where the formulas come from. Formula 1, where you are doing field. The genesis of all formula, energy of quantization, is what? HF. That is the starting point. Where this H is called Planck's constant. You'll be given the value in the exam, but should you not be given, you're supposed to know the constant. The constant is what's given as well. 6.63 times 10 raised to the power minus 34 joule seconds. Planck's constant. This F here is your frequency. Now, but from wave, we know that frequency is speed over wavelength. So, my second formula, if I substitute frequency here, my energy then becomes hc over lambda. This is the second formula you can use to solve questions on fields. Again, because I know that energy is also half mv squared. Energy is also half mv squared. So, I can equate this energy with this formula, so I can also have equal half mv squared. This m is always the mass of the electron, can also be hc over lambda. Then sometimes you use this formula when you have to calculate velocity. The short form of this formula, if you are calculating velocity, will be your velocity v. After taking everything to the other side, will be what? 2hc over mass of electron lambda all square root. You have this formula. Suppose you have to calculate what? Velocity of what? Of a moving electron. So this 2 multiplied by your h, which is your Planck's constant, multiplied by c. C is the speed of light. C is speed of light. Should you have a question like that? Speed of light, then me is the mass of electron. This speed of light is 3 times 10 to the power 8 meters per second. Then this m is the mass of electron. You may be given the constant or may not. The mass of electron is given as 9.11 times 10 raised to the power minus 31 kilogram. If it is a proton that is given, if you are given a proton, the mass of the proton is always 1.67 times 10 raised to the power minus 27 kilogram. If it is a proton that you are given. But normally this is how you calculate for velocity of a what? Of a moving electron in a what? In a field. But if you want more formula, this is not where it stops. There are so many formula you can generate from this. If you want more formula, download the UTME Learning app, subscribe, and you're going to see all lecture notes taught already for you. So we'll go back to this question. Now, what is the formula for stopping potential? The formula for stopping potential energy E is giving us EV. Where is E is what? Charge of an electron that is giving us 1.6 times 10 to the minus 19 joules. Why is V here is the stopping potential. Is it what? Is the stopping potential. So already we'll be giving E the energy. E is the energy. So if I make some, the stopping potential something the formula, my stopping potential will now be the energy divided by E. So if I both substitute, what will my energy? My energy is what given to us as 2.2 times 10 raised to power minus 19 divided by the electron, which is 1.6 times 10 raised to power minus 19. So we can see that. So if we divide, we see that this, we divide this. So our stopping potential will be 2.2 divided by 1.6. The stopping potential V. So 2.2 divided by 1.6 already gave us. That is our final answer. Divide gives us, we want it to also calculate for us and tell us what the answer will be to show that you are participating. Do that and tell us what the right answer will be in the option. God bless you. If you want more of this solution as you are preparing for JAMB and WAEC, kindly subscribe to Tutorsport Academy channel on YouTube. Follow our page on TikTok, Facebook, and then subscribe and download the UTME Learning app. Thank you. God bless.